So this is tutorial number 14, some measured value for the viscosity of ammonia gas as follow. So this is the temperature, 300, 400, 500, 6, 7, and 800. So, and then this is the measured value. So in this tutorial, so I would like to show you how people get the value of n numbers, or how you could have an idea if you do research in fluid by having a log-log graph. So that, for example, this is the data that you get. So what you could do is, so we know that previously that we have some kind of equation like this. So we have mu over mu naught equal T over T naught by the power of n. So and then actually the idea is we first we need to take the value of T naught here, the temperature, the reference temperature. So if you have here, it is okay for us to get the 300. Okay, so in this situation, actually you could take any type of gas as any type of temperature here as your reference temperature, but sometimes you need to think about the 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 error percentage. Normally people will take the low temperature. So the 300, it is around 27 degree Celsius. So mean it is just a room temperature. So it is might be we could handle that measurement, because here some measured value means the measurement was done. So it is good to have the value which is similar to the room temperature, because normally people will do precisely the measurement on that on low temperature. So let's say we take the T naught is equal to 300 Kelvin. So and then we change this term into log-log. So we have the log-log here, and then we plot all the graph. Okay, so because we already have the value, the T naught value is 300, and another value is here. So means that we could plot the graph. So and then we could find that the value of n here is 1.0451. So if you plot the graph, you will get this one. Okay, and then the value of n here, if you see, this is actually the gradient of that graph. So from the simple calculation of gradient, maybe you could use this point and this point. We could calculate, so you could get the value of n. The gradient is 1.0451. So and then we substitute the value in this equation. If we change this equation into this kind of equation, so we will have the value of n as 1.0451. That is the value of n that we use in previous calculation, which is 0.66, if I'm not mistaken. Okay, so this is the idea. So another idea that you could get from this solution is, if you do research in your master level, maybe you get a lot of data, and then when you plot it as it is, you will find that the data may be not easy to conclude. So what you could do is, please try to do the log-log graph. So you change the x-axis and the y-axis with log graph, and then you could calculate your own graph. By that, I think your supervisor could help you in that situation. So normally you will get very scattered data into a straight line or anything else that's maybe lead you to create or to conclude good conclusion later on. So this is another tricks in fluid mechanics, because if you read the textbook, for example, you will find that previous researchers do the curve fitting by changing the way they are present their graph. Normally they will use the log-log, the log-log graph.